The procedure to apply integration by parts on indefinite and definite integrals are the same. First, we choose which function will be our u and which function will be dv. Then we will derive u and integrate dv. In that way we will have u, du, dv, and v. Then we will apply the integration by parts formula. Once we set up and compute that formula, we will reverse all terms back to be functions of x. And finally, we will integrate. Let's solve the following example to understand this procedure. Notice that we can apply integration by parts because we have a product of two terms. Here, our task is to define which one will be our u and which one will be our dv. U will be the function that is easier to derive. Between x and root square of x plus 1, the easiest to derive is x. Therefore, 3x will be our u, which means that root square of x plus 1 dx will be our dv. In the second step, we derive u. With respect to x. This is equals to 3. This means that du is equals to 3 dx. Here dv is root square of x plus 1 dx. This can be also expressed as x plus 1 to the 1/2 dx. Here we need to integrate dv. And this will be equals to the integration of x plus 1 to the 1/2 dx. The reason why I put it in this way is because it's easier to see which formula we will use when we want to integrate. Now, so far we have learned how to integrate x to the 1/2 just alone. But let me teach you one additional property. If you have x plus a constant, elevated to any exponent except -1, the integration will be simply x plus a constant to the n plus 1 divided by n plus 1. In other words, This is the same formula that we have been using when we wanted to know, for example, the integration of x squared was simply x to the third divided by 3. However, in this additional property, if we have x plus 1 squared, this will be equals to x plus 1 to the third divided by 3. This is a very special property. Let's apply that property here. The integration of a derivative cancel each other. This is v equals the integral of x to the 1/2 is x to the 3/2 divided by 3/2. Therefore, the integral of x plus 1 to the 1/2 is x plus 1 to the 3/2 divided by 3/2. And remember, this is 3/2 because I added 1 to the exponent when I do the integration. Now, because we have 3/2 in the denominator, we can move it as 2/3 in the numerator. And this is our v. Another way that you can infer in the solution is because when the exponent is a fraction, like 3/2, the coefficient will be the inverse of 3/2, which is 2/3. Now, notice that we have already our four terms. We have u, du, dv, and v. Therefore, we can use the formula of integration by parts. The formula is the integral of u dv is equals to u times v minus the integral of v du. Here, what we want to do is we want to integrate 3x times root square of x plus 1 dx. This will be equals to, here we have u, which is 3x, times v, which is this, 2/3 x plus 1 to the 3/2. Minus the integration of v, which was again 2/3 x plus 1 to the 3/2 times du, which is 3 dx. Here we can simplify some terms. 3 divided by 3 is 1, so we have 2 times x plus 1 to the 3/2 minus, here we have 3 divided by 3 is 2, times x plus 1 to the 3 halves dx. In the case of the first term, this is the part of the solution, and we do not have to worry about. So this part is done. The only part that is remaining is to solve this last integral. But as you can see here, this actually is feasible using this property. This is, think as x to the 3 halves. The integral of x to the 3 halves is x to the 3 halves plus 1, which is 5 halves. So x to the 5 halves divided by 5 halves. So the only thing that is going to change is that instead of being only x, it's going to be x plus 1. In other words, the integral of x plus 1 to the 3 halves is x plus 1 we add 1 to the exponent, so this is going to be 5 halves divided by 5 halves. Finally, this is going to be 2x times x plus 1 to the 3 halves minus. Notice that we have in the denominator 5 over 2. This can be translated in the numerator as 2 over 5. 2 over 5 times 2 is 4 over 5 times x plus 1 to the 5 halves. And because this is an indefinite integration, we need to add a plus c. And therefore, this is the solution of this problem.